Okay, so we're going to start with diagram number 1 and the questions associated with it. So first one, what is the volume of the mechanical room? Show your formula. 12 by 8 by 8, 768 cubic feet, correct? Make sure you, on test day, these are all going to be multiple choice, and they might have 768 square feet. Volume is always cubic feet. Okay, so that's the answer to that one. And again, if anyone got anything wrong, let me know so that we can go over it. Number 2, is the mechanical room considered a confined space? It is considered a confined space because for it to be not a confined space, we would need to have 7,750 cubic feet of volume in that mechanical room, correct? And we don't, we only have 768, okay? All right,
I have a question
yeah, go ahead.
about that one. Is there a place in the book where it defines what a confined space is? Because I found that formula that said you need to pull air from outside if you don't have that volume.
Mm-hmm.
But it didn't necessarily say confined space.
Okay, so let's go over to the good practices book and let's take a look. I'm going to make this full screen so we can see it. So first, maybe I might start in the definitions. All right, so let's see. Let's go look at definitions and see if they have a definition for confined space in here. And I honestly can't remember if they do or don't. I think they used to, but let's see if they have a definition for confined space. Concealed, condensate, control, conversion, cubic foot. Okay, so they don't have a definition in there, but let me show you where we're looking at that kind of explains it for you. So I go back up here to, we're dealing with combustion air, so I want to find the section for combustion air. It's not section 3, that's gas piping. And it's not section 4, that's appliance installation.
Section 5, page
Section
78.
5. Okay, so if I just click on that, it takes me right there. Okay, so let's see. So he's talking about adequate volume or confined space. So we need to go find that example.
Required
Right
volume.
here, number 4. So if the volume of the room or space in which the fuel burning appliances are installed is equal to or greater than 50 cubic feet per 1,000 BTUs of combined input rating of all appliances in the space, this may be regarded as having required volume to provide combustion. So if it does not have required volume, Carlos, in the industry, that is called a confined space. If you do not have required volume, it's known as a confined space. They don't specifically say the word confined space in here. I think in one of the older books, they used to say, if it doesn't have the right volume, we call it a confined space. But that's just the industry terminology. So if you do not have required volume, it's a confined space. Okay, does that
Okay.
help?
Yeah,
Okay.
because I was just going through the book looking for confined
Yeah.
space and didn't find it. So,
So basically the answer is if it doesn't meet this requirement, it's called a confined space. Okay.
all right, thank you.
Okay, good deal. So let me go back to that one. Okay, so yes, it is a confined space because we would need to have that many cubic feet and we only have that much. Okay, what is the volume of the family room? Show your formula. Well, that's pretty easy. 12 by 24 by 8 gives us 2,304 cubic feet. Remember, cubic feet. They're going to try to trick you. They're going to put square feet in there, same number, but square feet. Number 4, if you pull combustion air from the family room, you will need 2 metal grills of what size? Trick question. You cannot pull combustion air from this family room, right? Don't have enough volume in there. If I add this and this, it doesn't even come close to equaling that, right? Everyone get that and understand that concept? Okay, good deal. They're going to try to trick you with that. If you pull combustion air from the family room, well, you can't in this case because you just don't have enough volume there to do it, okay? If you provide 2 horizontal openings to the outside for combustion air, what is the minimum required round pipe for each opening? So our correct answer is a 10-inch pipe. And here's the formula we used. We had 155,000 total BTUs. According to the code, we divide, because we're using 2 horizontal openings, we divide by 2,000. That means we need 77.5 square inches, and a 10-inch pipe will give us that. Is there anyone who didn't get that right?
Yeah, I didn't get it.
Okay. What did you come up with? Where'd you go? We got to figure out where you went wrong. That's what the important thing is, knowing where you made your mistake.
I got 7 inches. And
Okay.
I think I just might have missed a number.
Okay. So here's the key thing to remember. We've got to consider we've got 2 appliances in here that need combustion air, and the total BTUs is 155,000, correct? We want to try to use 2 pipes. So I'm going to go over to the Good Practices Handbook. Let me make this bigger so everyone can see it. Horizontal. Okay, so 2 pipes horizontal when communicating with the outdoors, 1 square inch per 2,000 BTUs. Okay, so that's on page 88. So again, it's all about knowing where to find the information. Back to the test prep. So again, the question was asking, if you provide 2 horizontal openings to the outside for combustion air, what is the minimum required round pipe size? So I go over here and I'm using 2 horizontal pipes. I need 1 square inch for every 2,000 BTUs. So my formula looks like this. I have a total of 155,000 BTUs. So 120,000 and 35,000 is 155 divided by 2,000, because that's what the code tells us. So we needed 77.5 square inches. Let's see, a 7-inch round duct only gives us 38.48 square inches. 8-inch doesn't work, 9-inch, so 10-inch is the biggest, next one that'll work to give us what we need. So do you know where you made your mistake, Tyson?
Yeah, I just didn't really understand the formula.
Okay.
And now that I could see it, it's
Yep. Okay.
a lot easier to understand.
So just remember, take your total BTUs and then go to the code and figure out what you need to divide by, because each one is different. There's, a 2,000, a 3,000, a 4,000, and a 1,000. So you need to know where to find the info. The chart will show you a round pipe area, but if you want to know the formula, it's pi r square. So it's 3.141 is pi. That's what we call a constant. And in this case, we're looking at a 10-inch pipe. So it's pi r square. R is radius. So times the radius. Radius of 10 is 5 times 5 times 5 equals, and if you go back to the chart, 78.53 is what they've got on their chart. So that's the formula, pi r square, but just use the chart. It'll save you from having to do math. Okay. Number 6, what size rectangular duct would meet the minimum requirements for a single opening to the outside? So again, here's the math. We have 155,000 BTUs. For a single opening, we divide by 3,000. We have 51.66 square inches, and B, 10 by 6, okay? Now earlier, Tim posed the question, well, if I stick a 10 by 6 grill on this 10 by 6 duct, I don't have that many square inches anymore, right? It reduces it. So on test day, just take the question for what it is. They're just asking you about the duct. They're not asking anything about the grill. Now, if they had a question that said, what size rectangular duct and what size grill, then you got to take that into account, okay? Make sense? All right, number 7. What size orifices are needed to properly derate this furnace? Did everyone come up with a number 44 orifice? Okay, good. Look at you guys. Okay, remember this thing, minimum. So what is the minimum size and type of connector for the water heater? Everyone get 3-inch single wall? See everyone nodding yes. number 9, we got 5-inch single wall is the minimum, okay? We could use, and if single wall works, we can always use double wall. But when they're asking you minimum size and type, the answer is always single wall, okay? Now, if we couldn't use single wall in this instance, and we could only use double wall, that would be the correct answer. Okay, what is the minimum common vent size for this application? 5-inch double wall. Okay, number 11, if the most remote appliance is 118 feet from the meter, what size main gas line is required to the mechanical room? Everyone gets C, 1.25 inches. Okay, and remember, they're asking to the mechanical room, so you've got to take into account total BTUs in that mechanical room. You might see this question, well, you did see the question, what line to either the water heater or the furnace alone? Then you would use the information from that appliance to do it. And the last one on this, if you use a single opening combustion air method for this mechanical room, what must you be certain of? That'd be C, all appliances must have a minimum of 1-inch clearance on the sides and back and 6 inches in the front. And you can find that right in the book. One opening. Okay, so if we have one opening, the confined space, and all appliances in the enclosure shall have a minimum clearance of 1 inch on the sides and backs and 6 inches in the front. Again, I can't emphasize to you guys enough, the answers are all in the book. You just got to know where to go to find them, okay? All right, so now we're on diagram number 2. Okay, so again, basic here. What is the volume in the mechanical room? Show your formula. 16 by 10 by 8, 1,280 cubic feet. Okay. Is the mechanical room considered a confined space? Yes, it is. Okay. We need a minimum of 5,000 cubic feet. We don't have that. What is the volume of the family room? Show your formula. Okay. 20 by 30 by 8, 4,800 square feet. If you pull combustion air from the family room, you will need 2 metal grills of what minimum size? Hey, in this case, if we combine the family room and the mechanical room, we now have more than 5,000 cubic feet, correct? So we can pull combustion air from this family room in this case. And to get the minimum size, we need 2 12 by 12 grills, okay? We have a total of 100,000 BTUs divided by 1,000, 100 square inches, okay? And remember, we got to take our reductions for metal grills, okay? Anybody get that one wrong? Because if you got that wrong, we need to go over it to make sure you understand it.
Well, I got it wrong, but I know what I did.
You know what you did?
Okay. Yeah, I divided it by 2,000 because it is doing the 2-pipe method.
Okay,
instead of just doing it by 1,000.
Yep. So here's what you need to remember. It's you're bringing all the air from indoors in this case. So they're asking you if you pull it from the mechanical room, so you're still indoors. Notice these say all air from outdoors.
It's for the 2-part system.
Yeah. So if you're pulling combustion air from inside, you need to be up in the all air from inside the building. Okay. And 1,000 BTUs per hour of total input rating. So make sure you understand the question, where you're pulling the combustion air from, okay? And as long as you know where you made your mistake, you're good then, okay? All right, let's see, where do we go? Okay, if you pull combustion air from the family room, the two grills must be located at what place? C, one in the upper 12 and one in the lower 12, right? It's right in the code. We just looked at it, okay? All right. What size rectangular vertical ducts, so that means going up and down, could you use to meet the minimum requirement for outside combustion air to this mechanical room? And the correct answer is B, because A does not meet the minimum cross-sectional dimension of 3 inches. Remember in the code for combustion air? So let me go back over here and just refresh you. You should already have it highlighted. Right there. Minimum dimensions of air openings should not be less than 3 inches. Okay. So if you build a duct for combustion air, one of your sizes cannot be less than 3 inches or less. Okay. So a 13 by 2 would give you the volume, but it doesn't meet the minimum cross-sectional dimension of 3 inches. Does that make sense to everybody? Okie doke. Good deal. You guys are doing great. What size orifices? Oh, let me get this back down so we can see our, okay. Orifices. Everyone come up with the number 49 on that one. Good. Everyone's shaking their head. Yes. Good job, guys. Look at all you guys.
Can you walk us through that? Because I got the last one right, but can we walk through it just so I kind of get
Yeah,
it down a little bit better?
absolutely. Okay. So they're asking us what size orifices are needed to properly derate the furnace. So the first thing I do is I go over to my diagram. They're talking about the furnace and orifice sizing. So what do I need to know about the furnace? Well, I need to know it's 60,000 BTUs, and I need to know it has 3 burners, or however many burners they tell you, and the pressure I'm dealing with. And I can tell you this now, every test question is always going to be on 3.5 inches of water column. Okay. So now that I've got that information, 60,000, 3 burners and 3.5 inches of water column, I've got to go over and derate it. So I can go into the good practices book. So on this one, we're in Bryan Head, right? Okay. So let's go back up here, go back to the book. Bryan Head. Okay. So Bryan Head, they give me some information. In particular, what I need to know is specific gravity and BTU per cubic foot, okay? So in Bryan Head, specific gravity is 0.56, BTU per cubic foot is 708. So let's go back to this here real quick. So I have 60,000 BTUs times 0.61 because that is my deration factor for Bryan Head. You got that one, Carlos? Standard deration factor. We always use 4%. So for Bryan Head, it's 0.61. So we'll go back over here to the test. 60,000 times 0.61 divided by 708. 708 is the BTU content per cubic foot for Bryan Head. Okay, that's how many BTUs or how much heat energy is in a cubic foot of gas over in Bryan Head. So again, the book shows you an example of the formula. So that comes to, when I do that formula, 51.69, okay? Now I've got to divide that by the number of burners. So remember in our diagram, I have 3 burners. So I come back over here, divided by 3 equals 17.23. So I need to find an orifice that will give me as close as possible to 17.23 CFH. Now, specific gravity is very important because every different place has different specific gravity. So this is the specific gravity chart, okay? So now that I've got the information that I need, so let me minimize this here. So now that I've got this information, okay, 17.23, that's what I need. I need to find an orifice at 3.5 inches of water column at a specific gravity of 0.56 that'll get me as close to that number as possible. So I come back over to the book. So we're looking for 17.23. So we scroll down to the orifice tables. Specific gravity, 0.56. That's the table we need to be in, right? We're at 3.5 inches of water column, and I need 17.23. So I just start going down that column till I find a number that's as close as 17.23 as I can get. Okay, we start getting down into here, and it looks to me like a number 49 will give me 16.91, and a 48 will give me 18.32. Of those two choices, which one is closer to 17.23? 16.91, correct?
Yeah. So with that one, you would just take your 17.23 and you would minus 16.91, see what that number is, and then, or if
Yep.
you were looking at, see if it was 48, you'd take 18.32 minus 17.23, and then whichever one of those numbers is closest, that's the one you go with, right?
Spot on, man. How many furnaces have you installed in your life?
None.
Oh, look at you. You've never installed a furnace and you already know how to derate them. You're amazing. All right. Good job. Good job. Okay.
Thank you.
Again, just need to know where to find the information, guys. It's easy. All right. Number 8, we should have came up with a 4-inch single wall. Number 9, 4-inch double wall. Number 5, this one is a little bit of a tricky one. Okay. So how many of you came up with B because you went over to the sizing book and saw this? This one is a little bit confusing, but I just want to show you what they're talking about. So over in the sizing handbook I gave you, this item here, number 6. Okay, so let me make this big again so you can see it. On page 31, it says, regardless of the results obtained from the sizing table, under no circumstance should the common vent be smaller than the largest connector. If both connectors are the same size, the common vent must be one size larger. So in this particular instance, let's go back over here, okay? We have 2 connectors that are the same size. And according to this, if you have 2 connectors that are the same size, the common vent must be one size larger. So if you read that and picked 5, you're good. But that is an old code. It has changed. If you found in the book that 4-inch double wall worked as your common vent and that's what you picked, you're good. You did a good thing. You got it right. This is an old code. It's not in the IFGC or the good practices book anymore, but I just wanted because I give you this book and this is an older book and that old rule is still in there. That's where it came from. But if you picked A on this one, on test day, you'll get it right because they got rid of this, okay? But you just need to know that it exists in there because I gave you some material that says that. All right, number 11, if the most remote appliance is 52 from the meter, what size main gas line is required to the mechanical room? Again, they're asking you to the mechanical room, feeding both appliances. Okay, so when they say mechanical room, how much to all the appliances? Everyone should have got A. And number 12, what would the volume in the mechanical room have to be for it not to be considered a confined space? And we'd need at least 5,000 cubic feet. All right, anything we need to go over on that one? Everyone good with that? Okay, so in this diagram, we're in price, got our vent heights, we got everything we need to know. Volume of the mechanical room, 12 by 10 by 8, 960 cubic feet. Is the mechanical room considered a confined space? Explain why or why not. It communicates directly with rooms of adequate volume. Notice there's no doors. Remember that rule about if there's no doors, you can just consider that all part of the mechanical room. That's how we got that one. Minimum size and type of connector. Should have got 4-inch single wall. Furnace, 5-inch single wall. Okay, common vent size, 6-inch double wall. How many CFH will the furnace burn when properly derated? Everyone get that one right? Everyone's nodding their head yes. Okay, again, your formula, just know where to find your information. Examples of the formula are in the book. What size orifice to derate the furnace? Should have came up with the number 45. And again, the formula is right there. Copy of the formula is in the book. The key is to make sure you're on the right specific gravity page, okay? That's where I see you guys screw this up. They'll be doing this formula, but they'll go over to the specific gravity page of 0.56 and pick an orifice from there. When in this case, because of where we're at in price, 0.62 is where we need to be. Okay, if the most remote appliance is 28 feet, should have came up with A, 3/4 of an inch. Again, they're asking to the mechanical room. What is the minimum size main gas line you would run to the mechanical room if you followed Questar's recommendation? Okay, Questar always recommends you run at least a minimum of 1 inch. Now that is not a you shall, it's hey, we recommend. Yeah, I can run a 3/4, but they recommend you run a 1 inch to allow for future expansion. That's what that's all about. Oh, here's a good one. Because of space restrictions, you are unable to run a 6-inch common vent. Is there anything that can be done to reduce the size of the common vent without changing the equipment BTU inputs? Well, we could change all of the connectors to B vent, because remember up here, we could get away with single wall, but if we change all of our connectors to B vent, it allows for a 5-inch common vent, or extend the common vent to 20 plus feet to allow for more BTUs. Because look, we got a 17-foot vent, and remember in one of the classes I talked about the for this vent, the better it vents, the more capacity it has, because it'll develop a stronger draft. Okay, so yeah, you can change to a 5-inch if you just change your connectors or make your vent taller. Everyone good with that? Understand that concept? Right on, man. Okay, how many CFH of gas will the water heater burn when properly derated? So again, you just use the deration formula. Okay, 40,000 times 0.77 divided by 896. I find that information in the book. I just go to price to the gas table. And what size orifice will be required to derate the water heater? Number 36 orifice. Everyone good on that one? Okay, sweet. You guys are doing excellent, man. You're gonna blaze through this test with flying colors. All right, diagram number 4. We're in Cedar City. We've got our information. So again, I'm just gonna go quick. Stop me if you got something wrong so we can go over it. So number 1, how many cubic feet of volume would be required for the mechanical room to have adequate volume? Well, it would need to have 4,300 cubic feet. What is the volume of the mechanical room? It's only 640 cubic feet. What is the volume of the family room? 3,456 cubic feet. If you pull combustion air from the family room, you will need 2 metal grills of what size? Another trick question. You cannot pull combustion air from this family room, okay? If I add this and this together, I don't get that, right? Okay. If you provide horizontal ducts to the outside for combustion air, what is the minimum required area for each opening? 43 square inches. Again, I just use the formula. I've got 86,000 BTUs. Okay. Horizontal ducts, meaning 2. What size round pipe would meet the minimum requirements to a single opening? That'd be a 7-inch. Again, the formula, 86,000 divided by 3,000, 28.66 square inches, or a 7-inch pipe. Can you do the math or just go to the chart? I think going to the chart's just a lot easier. Okay. What size orifices are needed to derate the furnace? We should have came up with number 45 orifices on that one. Again, our formula and specific gravity. Just this is where I see guys always make the mistake, is they're on the wrong SG table. So they're doing this off the 0.60 or the 0.63 or whatever table. Make sure you're on the right table. All right. Number 8, we should come up with 4-inch single wall. 4-inch double wall. So see rule on page 112D of the good practices. Okay.
What is the rule? Because I didn't do this one, but so.
Okay. Sorry. So see the rule in the site. Sorry, we're up here on this one. See rule on page 112 of the good practices. So I go to the good practices book. Let me bring this up here so it's big screen. So let me go back over here. So we have a connector run that is 9 feet long. Okay. So the maximum capacity listed in the tables for fan assisted appliances is reduced by 10%, and that is because the vent connector or manifold length cannot exceed 1.5 feet for each inch of connector diameter. So it can't be bigger than 1.5 of the diameter, okay? That's what the rule's telling us. So let's go back over here to this, okay? And let me minimize this, okay? So we got a 9-foot connector run, okay? And when you did the math and came up with it, you probably would have found that a 3-inch single wall would work, but because we have such a long connector run, 3 times 1.5, okay?
Yeah, so if I got this right, if we did use a 3-inch, our longest run would only length it could be is 4 feet and 5 inches, right?
If I was using 3-inch, I could only go, my run could only be 4.5 feet long, but I got 9-foot run there. Okay, so I've got to step it up just simply because of the length of the run. Okay, so again, back in the book talking about reductions that you have to take. So this is the gist of it. Vent connector manifold length cannot exceed 1.5 feet for each inch of connector diameter. So we did 3 times 1.5 says our run can't be longer than 4.5 feet. But if we did it with 4-inch, then it would work okay. Okay. Does that make sense? Does that clear it up for you? Or did I just confuse the crap out of you?
No, that's good. Thank you.
You bet. Okay. All right. Same thing here. We had that rule on page 31 of the sizing book, which I already covered. Just remember that rule is an old rule. It doesn't exist anymore. If you got 4-inch double wall on this, you're okay. So whatever the chart tells you, if the chart tells you a 4-inch would work in that, that's the answer you're going to pick. All right, what is the maximum BTU capacity for this water heater connector? Okay, 55.8, and we had a 10% capacity reduction because of that 9-foot connector run. Okay, that big long run. We want connectors to be as short and straight as possible. And number 12, if the fan-assisted appliance in this mechanical room does not have minimum clearance, what are the area requirements for vertical combustion air ducts? Well, if you're using multiple ducts, minimum clearances are not required when using multiple ducts, right? They tried to trick you. Just do the formula. 86,000 divided by 4,000. The only time minimum clearances are required is when you're using a single opening, correct? Okay, so again, watch your questions because they're going to throw trick ones at you like this, okay? All right, everyone good on that one? Any other questions, anything we need to go over? Okay, if combustion air is provided through 2 horizontal ducts, what is the minimum free area required for each duct? So 22 square inches, and Good Practices book talks about everything we need to know there. Everyone get that one right? If a 300,000 BTU boiler is added in the room where the furnace and water heater are located, and combustion air is supplied through 1 vertical duct, what is the smallest duct size that meets code? Okay, everyone come up with D, 10 by 12. And all we did was we added 300,000 BTUs to what existed, 44,000. We don't need to provide combustion air for this because it's a direct vent furnace, has its own combustion air. See, they try to trick you up there, okay? All right, everyone good there on that one? Seeing yeses, okay? If combustion air is provided through 2 vertical ducts, what is the minimum free area required for each duct? 11 square inches. Remember, we're only providing combustion air for the water heater because this is a direct vent appliance. This particular exam, more guys have screwed up because they added this to the equation. Okay, if you have a direct vent appliance that's got its own combustion air, which is exactly what this is, you ignore that from combustion air calculations. Okay, number 4. What size would a 20-foot branch line to the furnace need to be if the most distant appliance is 64 feet on a 4-ounce system? And we should have got a 3/4 inch on that one. Everybody get that right? Looks like I'm seeing a bunch of heads nodding yes. Good deal. Okay. If combustion air is provided through a single horizontal duct, what is the minimum free area required for the duct? 14.6 square inches, and I found the information I needed for that on the Good Practices book, page 89. Again, we're only providing combustion air for the water heater because this thing's a direct vent appliance. Okay. What size orifices are needed to properly derate the furnace? Number 48, there's the formula. Okay. Everyone get that one? And final question number 7. How shall the gas venting system for the furnace be designed and installed? B, per the manufacturer's instructions, page 93 on the Good Practices book, because it is a 90% 2-pipe sealed combustion direct vent. Before we wrap this up, are there any other questions?
I have a question.
Yeah, shoot.
In what order did you have your book set up? Because I know you kind of sent these to us in a specific order, and I have since mixed them all up. So
You
I don't know.
mixed your papers up, Carlos. Oh my God. What are we ever going to do? Well, here, let's see if I can help you out. I think it was on day 3 or 2. Part of the video shows how to put your book together, but let me show you real quick. So your book should start out with number 1, physical properties of natural gas and everything associated with it. Number 2, green sticker and general safety and everything associated with it. Number 3, gas piping and everything associated with it. Number 4, appliance install and everything associated with it. Number 5, combustion air and everything associated with it. Number 6, venting and everything associated with it. Number 7, appliance deration and everything associated with it. And finally, what we're doing today, test prep. So this is the order that I recommend you put your book together in, okay? And again, I believe it was either day 2 or day 3 video, I went through a little spiel about how to put your book together. Okay, does that help you out, Carlos?
Yeah, thank you.
You betcha. All right. Well, if we have no other questions, then there's just a few things we need to go over. Here is the current list of the only places in the state of Utah you can go and take the exam, okay? I recommend you call them first to schedule appointments. I don't know, every one of them has got different COVID protocols. You can also go on the RMGA website, should have this exact same information on it. I have this book, the IFGC, and that combustion analysis book. As long as you have those 4 books, if you don't have your study guide with you, everything you need is still in those books. Everything we've gone through, everything that's in here, okay? And you can have this book. The blue one is the most current version. If you have any problems on anything, you can always contact me directly. I'll talk on the phone with you. I'll do a personal Zoom meeting with you or whatever. Let me know how you do on your tests and let me know if you have any issues, okay? And remember, call them first because everyone's got different COVID protocols and shit going on and different schedules. And then make sure you study the material, go over and practice, know where to get the answers, and you guys will do just fine. Okay, if we have no other questions or comments, we'll call this one done.